Okay, back again. Had a tragic crash that lost me maybe about an hour and 40 of work. No, probably not that long, but well over an hour's worth of work. What I had to do to fix it. You'd think I'd notice since this window is here the whole time and with the crash takes down the window. You would think that, and eventually you'd be correct, but yeah, it took a while for me to notice. What I had to do was fix this rendering out of bounds. I thought this might be a problem when I added the mouse. I don't know how I convinced myself that it wouldn't be a problem, but it turns out it is a problem. But now we can put the mouse wherever we want over the screen and it's fine. Okay, so what have we missed? We missed a little bit of dependent typing. So what we did was started work on the actual algorithm, which is here. So it makes use of an easiness factor, an interrepetition interval, and a repetition number, and these are tracked for every single card. So in our card, we have the front, we have the back, and then we have the repetition number, the interrepetition interval, and the easiness factor. The special thing here is the easiness factor is not just a double. It starts at 2.5. It's not just a double, it's a specific new type, which is a double plus a proof that the value is greater than or equal to the minimum value. This is the minimum. So if we look in the algorithm, we have this. All right, so our easiness factor can never be less than 1.3. So we demand that to make an easiness factor, you must supply a proof that that this condition holds. Some things we found out along the way is that this doesn't work. Idris is not able to view that as a type. It only views it as a Boolean. So you need to compare it to true. Strictly, this is syntactic convenience because it should be this. But Idris does have an affordance for this, but no affordances for that, which I find fairly sad. We also found out that this will introduce an implicit type variable minef, and it won't refer to the minef here. So what will happen is it won't be able to automatically solve this constraint here. So here I've used a REFL. I've said, make me an EF with this value and, figure it out, right? Like, figure out that 2.5 is greater than or equal to 1.3. I don't need to prove that. Just figure it out yourself. But Idris is unable to do that when it thinks this is a variable. So we had to have a module and specifically namespace it. The other thing you can do is you can capitalize the first letter. We also found out that modules must begin with a capital letter, and they also must match the name of the file, so rename the file. All of these things I find to be quite annoying. I don't like these restrictions. They're kind of arbitrary. It makes the whole thing feel kind of undercooked. But we will persevere because I have a goal. So I'm going to deal with these annoyances for now. Okay, so let's get back into it. In the middle of writing the update card, given a score. So that's just this algorithm here, right? So you get a score, and then it goes through and updates a bunch of stuff. And, that's basically it. Given a score, it updates a bunch of stuff. And the question I was having is, so most offside rules languages, or maybe I'll rephrase that. In an offside rule language, you would expect to be able to do something like, so if this equals 1 0 and then this equals 2, whatever, it doesn't matter. You would expect that because these two line up, it comes under the let, right? So this is implicitly a something like that. I don't know if Idris supports that. But more to the point, I don't know what will happen in this case, where the offside rule, we want to line these two up, but this case statement, maybe it will think that whatever we write here is part of the case statement, because it's offside from the case. And maybe what we need to do for the case, well, I guess it doesn't need to be that far, it just needs to be that far. Maybe we need to do that for the case statement. I don't know the answer to this question, so we're going to try it out. The first thing I'm going to do is just do that to see what happens. Okay, yeah, so, right, it demands, we'll keep that for now, probably something like this. Oh, no, I'm being silly. Let's get rid of that. Okay. This is what I love about these dependently typed languages. The error message is always very good, very helpful. Yeah, you just don't know what that means? Okay, what if I do this? Yeah, you're expecting an in. That's fine. Okay. Let's go in C. We'll just return C. You cannot unify card to nat and integer. I see. Here. I was a bit fast and loose with the cast, but this is a curious mismatch between card to nat and integer. Oh. Wait, O? I don't know about O. What's going on here? This should also be value, I think. Okay, you still don't like that? Where are you complaining? Let I equals. These line up? Looks like it. Well, do I accidentally have like a tab somewhere? I don't think that's the problem. No, cool. Oh, wait, it might have been? Oh, you're complaining about this. Okay. Mismatch between card to nat and integer. 44. Oh, no, absolutely right. There should be card.n. When unifying nat and integer. These should both be naturals. Can't find an implementation of num for card to nat. What are you smoking? I know exactly what they're smoking. Unifying double with card to nat. Let I equals, yeah, this should be the previous one. Yeah, double and nat. Okay, that's fine. That's fine. I don't know. Can I cast this? I don't really know how this works. You can't unify into... Why do you think it's an integer? That's very interesting to me. C.n is a natural. And we're multiplying C.I, which is a natural, by a double. We do know that this double is greater than 0, so we should know that this is greater than 0, but clearly it just doesn't. That's fine. Oh, these are two chars. Okay. Two doubles. Yeah, okay. Okay, so we do just do a cast. That's fine. To bits 8, to bits 16, 32, 64, int, to nat. Here we go. Integer to nat. I don't know how I feel about that. Where does this come from? Is this in the prelude? What is this? This is prelude cast. Oh, this is for num. Integer to nat. If integer to bool, believe me, I, else 0. Oh, interesting. Force evaluation. That's really interesting. I wonder... Like, this turns out to be fine for my uses. But that logic is not encoded in our program. It's just fine because I know that it's fine. So what is this? This is a double? Yeah, so here's the thing. It's not encoded in the logic of my program that this is valid, right? So ideally, I should have to do this conversion, there should be a version of this conversion which you give it two things and you have to prove that they multiply to a positive number. And the way that I could do that here is I could say this is a natural. This is greater than or equal to 1.3, I think. And so because both of them are greater than or equal to 0, their multiplication is greater than or equal to 0. And so that's a proof that this cast is okay to do. I think Agda has something like that. Maybe. I don't know. I don't know if Idris does. So let's take a look at data nat. Probably not order, probably not view. I don't really know what views is though. I don't know what that is. Okay, interesting. Hyper, what is this? Not both 0. Indeed. Reflexive nat LTE.